This is April to August 1986 map, Virgo and Corvus. The departure of the comet. Chapter 5. Visiting the Comet. This close-up of Halley's coma was taken through the 60-inch reflector at Mount Wilson Observatory in 1910. I got the camera on the wrong side. Yeah. That's train. That's a train. Train, baby. One of our most significant technological achievements since Halley's last visit has been the development of machines capable of breaking the gravitational bonds of Earth to explore other worlds. Through our mechanical surrogates, we have stepped onto the surfaces of Mars and Venus, toured the distant worlds Jupiter and Saturn, and are even entering into the vast sea of interstellar space. Okay, go. In 1986, 4 robot spacecraft from 3 nations will make the first detailed on-site measurements of a comet and its environment. The target, of course, is Halley. Why? What's so important about Halley that several nations are spending millions on space probes to fly past it? Scientists think of comets as relics of the young solar system, balls of dust and snow that have remained virtually unchanged for over 4,000 million years. If this is true, if comets really are frozen fossils of the gas cloud that formed the solar system, then by studying them, we can delve into the very processes that shape the sun and planets. Although astronomers have been studying comets from Earth for centuries, the detailed composition of a comet's nucleus remains unknown. The only way to get this information is to send probes through the coma and tail of a comet. I looked up the results, and it apparently was found that it's a large potato-shaped rock in space. I don't remember its contents. So this complicated a bunch of colors right here. The lunar encounters. So from March 30th to April 24th to September 28th to October 22nd to December 23rd in 1983. It appears, okay, this is moon's orbit. Okay, so this circle is the moon's orbit. And it looks like it comes in here and loops around that way and then up this way and then down that way and down here and then back up and then over, loopy loops out that way. Or it oh no, this is confusing to follow. So try this again. That way, and then into the orange, and then into the yellow, and into that one, and into that one, and then out. Okay. In August 1978, the third International Sun-Earth Explorer satellite was launched into the gravitational balance point between Earth and Sun. The spacecraft's original task was to monitor the Sun's wind of charged particles, but after 4 years of operation, it began a new mission, a study of the electrically charged particles that trail behind Earth, its magnetotail. Through 1983, a flyby past Comet Jacobini-Zinner in September 1985, and long-distance monitoring of Comet Halley in 1985 and 1986. For its new mission, the craft received a new name, ICE, the International Comet Explorer. ICE's second life began with what may be the most complex set of orbital changes ever undertaken by a spacecraft. It didn't contain enough fuel to reach the comets, so mission planners sent it into a series of looping trajectories that swept it past the moon 5 times. Each lunar flyby gave the spacecraft a gravitational boost that increased its velocity and changed its direction. The last one, which occurred in December 1983, brought ICE within 62 miles of the moon's surface. The probe plunges through the tail of Jacobini Zinner on September 11th, 1985, passing within 2,000 miles of the Comet. 6 weeks later, the spacecraft moves to the first of two locations between Comet Halley and the Sun. Its October 1985 approach places ICE 85 million miles ahead of the comet. The probe's March 1986 encounter takes it to within 20 million miles. From both upstream positions, the craft will observe the solar wind a day or so before the particles reach Halley. Earth-based telescopes and the European, Japanese, and Soviet probes will then observe the interaction between this measured solar wind and the comet. By 1987, ICE will be 74 million miles from Earth. This distance far exceeds the range for which its radio transmitter was designed, and even the sensitive tracking stations of the U.S. National Aeronautics and Space Administration will lose the spacecraft signal. ICE, the International Comet Explorer. Paradoxically, Comet Halley is not the best specimen for close-up study. It has made at least 28 trips around the Sun, and its material has been considerably modified through melting and refreezing. The ideal subject would be one of the long-period comets that take hundreds of thousands of years to complete an orbit and have probably swept through the inner solar system only a few times since leaving the Oort cloud. I mean, you want to see everything. Otherwise, what would you compare it to? You want to see as much as you can. But no one can tell when such new comets are coming. But no one can tell when such new comets are coming, so that leaves the short period comets, those observed frequently enough that their orbits are well known, as candidates for exploration. From this group, the best candidate must be bright enough to observe from Earth as well as space, and it must have an ample supply of gas and dust. There's only one comet meeting these criteria, which is scheduled to pass near Earth this decade: Halley. Space probes from Japan, the European Space Agency, and the Soviet Union will fly past Halley in March 1986. The United States abandoned plans for a mission to the comet, but did manage to redirect a previously launched satellite so that it could fly past a different comet, Jacobini Zinner, in September 1985. After this encounter, the spacecraft, originally called the International Sun-Earth Explorer and now renamed the International Comet Explorer, or ICE, will then work upwind of the other space probes to measure particles emanating from the Sun before they interact with Halley. So it was ISEE, IC, and now it's ICE, ICE. Okay. The first Halley probes to leave Earth were the twin Vega spacecraft of the Soviet Union. Vega is an acronym formed from the Russian name of the mission, Venera Galay. Launched in December 1984, the Vegas first traveled to the planet Venus, where they deposited landing probes in mid-June 1985, and then used the planet's gravity for a boost toward Comet Halley. Vega 1 will swing closest to Halley on March 8, 1986. Vega 2 will fly by about a week later. Both craft carry a wide-field camera to photograph the coma and act as a finder for a narrow-angle camera, which can resolve features on the nucleus as small as 600 feet across. Despite the spacecraft's distance of 6,000 miles. Why so far? The relative speed between each space probe and the comet is very high, so high that even the fine dust of a comet could severely damage the spacecraft. Although the Vegas are protected by a thin shield of aluminum, the Soviets will probably keep at least one craft about 6,000 miles from the nucleus. Since they have two spacecraft, one of them may be allowed to venture close to the nucleus, taking photographs and measurements until it is destroyed. One instrument will record the rates at which gases flow out of the nucleus and determine their composition, while another photographs the nucleus in infrared light. Infrared observations will tell scientists the temperature of the nucleus and surrounding dust particles, and the temperature and composition of the comet's gas. In addition, each Vega carries a magnetometer, magnetometer. Okay, so starting again. In addition, each Vega carries a magnetometer to sense magnetic fields and a dust detecting system to measure the speed and number of particles hitting the spacecraft's shield. In July 1985, about 7 months after the Vega probes were launched. After dropping instruments to the surface of Venus, the twin Soviet Vega spacecraft used the planet's gravity for a boost to Halley's Comet. A movable instrument platform carries the cameras, while the spacecraft body houses most of the other instruments. The Soviet Vega spacecraft. So, in July 1985, about 7 months after the Vega probes were launched, the European Space Agency's Giotto spacecraft blasted into orbit from Kourou, French Guiana. Giotto, the most sophisticated of the three Halley missions, is named after Giotto di Bondone, the Florentine artist who painted Halley's Comet in the 14th century. See Chapter 2. This one's the one from Albert Durr. That one. After cruising through space for 7 months, Giotto will finally reach its target on March 13, 1986, less than a week after the arrival of the first Soviet probe. Giotto should come within 300 miles of the comet's nucleus, passing it at a velocity of about 40 miles per second. Most scientific measurements will begin only a few hours before the probe's closest approach. The mission will likely end near closest approach, since high-speed cometary dust particles will probably destroy the spacecraft. To protect the probe during the early stages of the encounter, Giotto has a dust shield to intercept most of the oncoming particles. This consists of a thin sheet of aluminum backed by a thicker sheet of Kevlar, the stuff used in bulletproof vests and battleship plating. Battleship plating made of Kevlar. Interesting. So, up the top here, there's Giotto, and this reads, Giotto, the European Space Agency's probe to Halley, is probably the most sophisticated mission. If the craft survives a 60,000-mile passage through Halley's dust coma, Giotto may pass within 300 miles of the nucleus. Giotto's power comes from solar cells girdling the outside surface of the craft. Where? All the probes to Halley's comet are powered by solar cells, which generate electricity from sunlight, but only Giotto will attempt to penetrate deep into Halley's dusty, gassy coma. As the craft encounters denser swarms of dust particles, the high-velocity impacts will probably sandblast the cells, seriously degrading their ability to generate power. Right up to the end, however, Giotto's 4 onboard batteries should provide full power. Dust impacts may also create another, more serious problem. Long before reaching Halley's solid nucleus, the Giotto probe must plow through the tens of thousands of miles of dust and gas that surround it. At Giotto's high speed, a truly massive dust particle, one weighing, say, a few thousandths of an ounce, striking the outer rim of the dust shield, could knock the spacecraft out of its alignment with Earth, causing a loss of radio contact. Giotto would continue sending information until its destruction, but the radio beam would miss Earth entirely. Fortunately, the likelihood of encountering such a heavy particle is very small, if the craft avoids the dense jets of fresh material erupting from the nucleus. These dust jets pose still another problem for those attempting to guide Giotto to the solid core of Comet Halley. Once Halley fell far enough into the solar system for sunlight to evaporate its ice, a coma of gas and dust formed that completely hid the nucleus from observers on Earth. Scientists on Earth may know the position of the nucleus to no better than 300 miles. Astronomers could calculate Halley's position if they could rely on its nucleus to follow a simple path, one controlled solely by the sun's gravitation. The dust and gas spewing from the comet's nucleus, however, preclude its following such an idealized orbit. The outgassing material produces a rocket-like effect that pushes the comet off its predicted course. Giotto's mission analysts predict a 40% chance, they write the word percent, that the spacecraft will miss its target by more than 300 miles, possibly causing the craft to make an undesirable flyby past portions of the nucleus not illuminated by the sun. The aim of... Hold on. Before I read that one, let's look at this picture of Japan's Halley probe called Planet A will examine the comet from long distance. It is equipped with 2 instruments, a camera that senses ultraviolet light and a device for analyzing the solar wind. The aim of Giotto's mission is to determine the composition of the coma and the chemical and physical processes within it, find out the composition of dust particles and the ratio of dust to gas, provide high-resolution images of the nucleus, and investigate the flow of ionized gas in the vicinity of the comet and its reaction to the solar wind. This picture of these two red dots on this side, and these blue and green dots on this side, kind of see the two tiny red dots there. Turn on do not disturb. No. The above diagram shows Giotto and the two Vega probes at their closest approach to Halley. Okay, so blue is nucleus, green is Giotto at 3 miles, and red is Vega 1, Vega 2 at 6,000 miles. So the above diagram shows Giotto and the two Vega probes at their closest approach to Halley's nucleus. On this scale, planet A would be 5 feet away. So the Jap spacecraft is like way over here. So the Vegas are getting pretty damn close, but Giotto is getting very close. So the aim of Giotto's mission is to determine the composition of the coma and the chemical and physical processes within it. Find out the composition of dust particles and the ratio of dust to gas. Provide high-resolution images of the nucleus and investigate the flow of ionized gas in the vicinity of the comet and its reaction to the solar wind. To accomplish these goals, Giotto will carry 10 scientific instruments, including a camera, dust detectors, and several experiments designed to study the electrically charged particles around the comet. The fourth spacecraft to visit Halley will be the Japanese Planet A, launched from southern Japan in mid-August 1985. This craft will fly past the comet about 5 days before Giotto on March 8, 1986. Passing far from the active areas of Giotto, will traverse and approaching no closer than some tens of thousands of miles from the nucleus. Fly past the comet about 5 days before on March 8, 1986. Passing far from the active areas Giotto will traverse and approaching no closer than some tens of thousands of miles from the nucleus. So, anyway, they're saying it's all in August 85. March 86. March 13th, 1986. All right, that means Giotto will be near Comet Halley, March 13th, 1986. This is the southern latitude map. Morning twilight, latitude 35 degrees south. And this is when Giotto was supposed to be there. So, on March 8th, 1986. That's March 20th to April 1st. So still this one. All of the probes are going around there. The fourth spacecraft to visit Halley will be the Japanese Planet A, launched from southern Japan in mid-August 1985. This craft will fly past the comet about 5 days before Giotto on March 8, 1986, passing far from the active areas Giotto will traverse and approaching no closer than some tens of thousands of miles from the nucleus. All right, back to this. It's like the sun is glaring us. Still on this page. Planet A's task is to observe the growth and decay of Halley's coma, measure how fast the cloud of hydrogen atoms around the nucleus expands, and monitor the interaction between the comet's gases and solar particles. Planet A carries only two instruments, a camera that records ultraviolet light and a solar particle analyzer. The camera won't be able to see Halley's 3-mile-wide nucleus from the probe's location, but it will provide detailed pictures of the coma's structure. While Giotto photographs the nucleus close up, Planet A will be photographing the surrounding gas and dust in the Comet. All four spacecraft, plus the U.S. contribution of ICE, complement one another. The Soviet Vegas are best suited for providing photographs, while Planet A and Giotto are better equipped for experiments involving the comet's glowing gas. In addition, astronomers throughout the world will study Halley from space-borne telescopes in orbit about the Earth, as well as from mountaintop observatories. Halley's latest appearance heralds an unprecedented degree of international cooperation in the exploration of the solar system. Despite this technological assault on Comet Halley, scientists are already looking at more ambitious space missions. The United States, for example, is proposing a rendezvous with Comet Kopf, a short-period comet less active than Halley, but much more accessible. All of the missions to Halley are flybys. The probes encountered a comet much as a bullet encounters its target. A rendezvous mission, on the other hand, involves catching up to and traveling alongside a comet for several years, monitoring all of its subtle changes as it circles the sun. The space probe currently envisioned would use parts from previous U.S. space missions and would follow Comet Kopf for 2 years. Is this what a comet's nucleus really looks like? Photographs from Giotto's perilous mission may tell us. The AI says that it's a potato-shaped object with very little active surface. Right, big hunk of, and that it's darker than coal. It's a vast, dark space potato. Couple of kilometers big, I think. And we had a few years ago that a man did manage to land a probe on a comet while wearing a nice anime shirt. But that lies years in the future. Right now, we don't yet know what the missions to Halley will find. It's safe to say, however, that the data they return will answer the most obvious scientific questions. Just as surely the missions will raise a lot of new questions that delve even deeper into the mystery of the nature and origin of comets. Further reading. Introduction to Comets by John C. Brandt and Robert D. Chapman, Cambridge University Press, London, 1981. Two NASA astronomers give a comprehensive, fairly technical introduction to cometary science, past and present. The Comet Book, a guide for the return of Halley's Comet, by Robert D. Chapman and John C. Brandt, Jones and Bartlett, Boston, 1984. A popular, non-technical version of the above book. Comets, edited by Laurel L. Wilkening, University of Arizona Press, Tucson, 1982. A 766-page volume of technical papers on various aspects of cometary research. Comets, a descriptive catalog by Gary W. Cronk, Enslow Publishers, Incorporated, Hillside, New Jersey, 1984. This book contains detailed descriptions of more than 650 comets including basic scientific and historical information. Edmund Halley by Angus Armitage, Thomas Nelson and Sons Limited, London, 1966. A detailed semi-technical account of Edmund Halley's life and work. Edmund Halley, Genius in Eclipse by Colin Ronan, Doubleday, New York, 1969. A biography of Halley intended for a general audience. Articles. Backtracking the Comets by Francis Redding, Astronomy, August 1982, pages 6 through 17. Brighter Prospects for Halley's Comet by John E. Bortle and Charles S. Morris, Sky and Telescope, January 1984, pages 9 to 12. The Cometary Atlas in the Silk Book of the Han Tomb at Mawagdui by Ji Zezond, Chinese Astronomy and Astrophysics, March 1984, pages 1 through 7. Comets, Death Stars, and Extinctions, The Rise and Fall of a Scientific Theory by Ray Grasshall, Astronomy, March 1985, pages 18 to 22. Death Stars? When was Star Trek made? Star Wars? When was Star Wars made again? Star Trek was made in the 60s, right? Comets, Keys to Our Solar System by Deborah Malloy Elmo-Green, Astronomy, March 1985, pages 6 to 17. Four Probes to Comet Halley by Jesse Eichenlaub, Astronomy, September 1983, pages 16 to 22. Giotto's Portrait of Halley's Comet by Roberta Olson, Scientific American, May 1979, pages 160 to 170. Observing Aids, Sky Calendar, Abrams Planetarium, Michigan State University, East Lansing, Michigan. This monthly publication provides simple maps for finding the moon and planets. The Star Book by Robert Burnham, Astromedia Corp. And Cambridge University Press, Milwaukee, 1983. An introduction to the constellations visible from the northern temperate latitudes, containing 8 sky maps, 2 for each season. Keep tabs on Comet Halley's progress with astronomy, the most popular English-language magazine about astronomy and outer space. And the picture credits. All courtesy of Library of Congress or Mallet's Description de l'Univers, 1683. Page 2. It's from 1682. It doesn't say that down here. It says an early woodcut. That's from 1682. All 9 planets circle the sun in nearly the same plane, but Halley crosses this plane only when its elongated orbit brings it into Earth's vicinity. Also, Pluto is at a slightly off-kilter orbit. And, here's the history from the Silk Book. And then, of course, the Bayeux Tapestry. And that there. Giotto di Bondone's Adoration of the Magi. The work was completed in 1304, 3 years after a spectacular visit from Halley's Comet. However, I have heard a theory that the star of Bethlehem is actually just a conjunction of Jupiter and Saturn. Yes, from what I read, viewing it from Australia was the best. This is the one that looked like in 1910. Back cover: The Path of Halley's Comet. All the way through space. The path of Halley's Comet across the sky from 1982 to 1987. Halley swings across 3/4 of the sky in only 7 months after spending years moving only a few degrees. Its motion across the sky reflects not only its own motion around the sun, but that of the Earth as well. As Earth moves around the sun, the comet traces a loop because Halley is close to us relative to the very distant stars. Plunging through the inner solar system, Halley makes its closest approach to Earth on April 11th, 1986, 2 months after it swings past the sun. It begins on that side. So October 16, 1982, astronomers recover Comet Halley with the 200-inch Palomar telescope. The comet is over 1 billion miles from Earth, just beyond the orbit of the planet Saturn, and more than 19 million times fainter than the faintest star visible to unaided eyes. Apparently because it's a potato-shaped object darker than coal. November 1st, 1985. Although still more than 100 million miles from Earth, Halley is easily visible as a diffuse spot in binoculars over here in Taurus. And then as it reaches Aquarius, passes under Pegasus. December 15th, 1985. The comet is now bright enough to see without optical aid, but only from dark locations. From now to the end of January 1986, the comet is best placed for observers at mid-northern latitudes. February 9th, 1986, Halley reaches perihelion, passing within 55 million miles, 89 million kilometers, of the sun's surface. That's here in Aquarius. And then Capricorn, March 1st, 1986, the comet is now approaching Earth on the outbound leg of its orbit around the sun. This marks the beginning of the best viewing for observers in the southern hemisphere. By April, Halley is overhead at dawn as seen from mid-southern latitudes. March 13, 1986, the European Space Agency's Giotto spacecraft flies past Halley's icy nucleus. April 11, 1986, the comet swings closest to Earth, passing only 39 million miles, 63 million kilometers away, over here in Centaurus. Because it doesn't follow the path of the planets, it's going through different constellations. And I think it's significant that it's in Aquarius at that time. in February anyway. And it moves into Sagittarius, Scorpio, and Centaurus. And then it starts to go away. April 15, 1986, it's Centaurus. And May, and then January 1st, 1987, is it does this little loopy loop. April 1st, 1987, the comet lies about 425 million miles, 685 million kilometers from Earth, and is 1,300 times fainter than the faintest star visible to unaided eyes. Over in Corvus beneath Virgo and above Vela. May 15th, 1986, Halley is again too faint to see without binoculars or a small telescope. Anyone with such equipment may be able to view the comet until late July. Oh, wait, this is May 15th, 1986, but okay, that's pointing to this part where it's before it goes loopy loop. These pages from Edmund Halley's notebook contain his original observations of the comet that bears his name. And then Halley's orbit for the comet of 1680 as it appeared in Newton's Principia. An alarm to Europe by a late prodigious comet seen November and December 1680, with a predictive discourse together with some preceding and some succeeding causes of its sad effects to the east and northeastern parts of the world, namely England, Scotland, Ireland, France, Spain, Holland, Germany, Italy, and many other places, by John Hill, physician and astrologer. The form of the comet with its blaze or stream as it was seen December the 24th, anno 1680 in the evening. London, printed by Bruges for William Thackeray at the Angel in Duck Lane, 8th of January 1680 and 81. Some Renaissance era English right there. Star maps for the Northern Hemisphere. It behooves you to learn your star maps, people. My friends. This is star maps for the Southern Hemisphere. This is September to December, and this is March to May. September to December, March to May. And there it is, going through Sagittarius. Scorpio, Virgo, Scorpio, Sagittarius, Cap. Okay, so yeah. The inside cover. Let's see what the inside cover, courtesy Library of Congress from Un Autre Monde by J. Grandville, 1844. Very interesting paper. This one reads Commentary in Congress. And there's Earth in October and Earth in May and Halley's chart. Or west. And then reliable meteor showers at Aquarids on May 4th, 20 meteors hourly rate. And the Orionids on October 20th, 25 meteor hourly rate. And then, of course, the Perseids on August 13th with 50. The Leonids on November 17th with 10. And the Geminids on December 13th with 50. Well, 10. Well, the Tunguska again. Hmm. Hmm. 40 degrees north. These are the 40 degrees north latitude maps for December 22nd, 1985 to January 10th, 1986. And then January 10th to 25th of 1986. Halley appears to be in Aquarius. And the moon passes, from here by Jupiter to Aquarius and into Pisces. But then from the southern latitude, this is still this is still okay. This says evening twilight. This says morning twilight, March 15th to April 5th, 1986. 40 degrees north. Passing Sagittarius at this time. April 17th to May 15th, passing the neat Virgo toward Leo. Still 40 degrees north. And from 55 degrees north, twilight doesn't quite end before Halley sets, but the moon's light washes out the fading comet and spoils the view until the 25th. 2 hours after sunset. This is evening twilight. Okay, now here's the Australian one. Yeah, in Aquarius, and then in Capricorn. December to January, it's in Aquarius, and then February to March, it's moved to Capricorn. So let's see. March, April, December. Scorpio. North latitude. The 17th to May 15th. First. Under Corvus. Yep. It's backing up and going back to winter here. May to March and April. This book was supposed to contain Now, this book was supposed to contain some kind of kit to build a model with, but it isn't here. I found this book in the used bookstore. And I have looked it up on Amazon. There's only like 1 or 2 copies left in the world. But very good, very interesting book. I really found it a marvelous exploration of space and stuff I didn't know about that happened before I was born. Here's the ICE. The IC and then the ICE. And the Soviet Vega spacecraft. Special thanks to Ruth Freitag, Science and Technology Division, Library of Congress, and Steve Edberg at JPL, the Jet Propulsion Laboratory. The Edwin Salter. Oh, yeah, see. Page 7 left, courtesy Library of Congress, from folio 10 of the Edwin Canterbury Psalter. New York Public Library, Rare Books and Manuscript Division. Astor, Lennox, and Tilden Foundations. Then page 8, the Bayou Tapestry, 1966, Norman Denny and Josephine Filmer, Sankey's courtesy. Athenian Publishers Incorporated, page 9, courtesy European Space Agency. Page 10, courtesy Jet Propulsion Laboratory. Page 11, courtesy of Library of Congress. Page 12, right, Royal Society left. Royal Greenwich Observatory, courtesy Nature, bottom from Introduction to Comets, page 16, page 13, bottom. Houghton Library, Harvard University, page 14. Oh, yeah. From the Mawadui Silk Book. I should probably read this. So, cover, Thomas L. Hunt. Inside cover, courtesy Library of Congress, from Un Autre Monde by J. Granville, 1844. Page 2, top, courtesy Library of Congress. Comets signify a corruption of the air. They are signs of earthquakes, of wars, of changing kingdoms, great dearth of corn, yea, a common death of men and beasts. Leonard Diggs, Prognostication Everlasting, 1576. bottom from Mallet's Description de l'Univers, 1683. Yeah. Page 3, top, adapted from Introduction to Comets by John Brandt and Robert Chapman. That would be that picture. After a few passes near the giant planet Jupiter, a comet may become a permanent resident of the inner solar system. Halley crosses the plane only when its elongated orbit brings it into Earth's system. Page 4, left. Thomas L. Hunt, bottom right, courtesy Library of Congress from Illustrated London News, April 23rd, 1910. Oh wow, there's a lot of pictures on page 4 here. Bottom right, from Illustrated page. Comet Halley in 1835, second from left, another 19th century comets. There, that one. It says that Halley's is 3 miles across its nucleus. And the coma is the thin gaseous halo around the nucleus. And the dust is always facing away from the sun, even if the comet's heading into it. Run through a digital image processor, photographs of Halley in 1910 revealed the arc jets in its coma. This is page 5. Let's see. Picture credits for it. April. Page 5, top left, Claude Nuclear, top right, S. Larson, Lunar and Planetary Lab, bottom right, courtesy Z. Sekiana and S. Larson. Top left, Claude Nuclear. Photograph. Comet Bennett over the snow-covered Pyrenees. S. Larson, Lunar and Planetary Lab. Bottom right, courtesy Z. Sekiana and S. Larson. Page 6, top, Metropolitan Museum of Art. Left, redrawn from the Mawagwi Silk Book. Let's go with page 6. Courtesy of the Museum of Art. The 16th century engraving Melancholia 1, artist Albrecht Dürer set a brilliant, dynamic, but not very realistic comet into the background. I don't know, I like it. Come on. Right. Albert Durr. The Metropolitan Museum of Art. Left, redrawn from the Mawagdui Silk Book. Page 7, left, courtesy Library of Congress. And folio 10 of the Edwin Canterbury Psalter. Right. New York Public Library, Rare Books and Manuscript Division, Astor, Lennox, and Tilden Foundations. Canterbury Psalter. Comet drawn at the bottom. Very, very faint. Although this picture was inspired by the comet's 684 appearance, it wasn't actually executed until 1493. It appeared in Hartmann Schedel's Nuremberg Chronicles. Right, I could read German names upside down. Hartmann Schedel. And a Canterbury Psalter with the comet at the bottom. And then the next page, Leo 10 of the Edwin Eadwine Canterbury Psalter, right? Public Library, Rare Books, Manuscript Division, Astor, Lennox, and Tilden Foundation. Page 8, from the Bayeux Tapestry. 1866, Norman Denning and Josephine Fulmer. Thank you, courtesy of Athenian Publishers Incorporated. And then Giotto di Bondona's Adoration of the Magi, one of a series of frescoes that decorates the interior of the Arena Chapel in Padua, Italy. The work was probably completed in 1304, 2 years after a spectacular visit from Halley. Back to the last page again. So Norman Denning, Josephine courtesy Publishers Incorporated. Page 9, courtesy European Space Agency. Page 10, courtesy Jet Propulsion Laboratory, JPL. And Halley, his notes, and Newton's notes. Newton's Principia. Halley himself. And here's some stuff from JPL on the planes inside of shapes. Ellipse, parabola, and hyperbola. Ellipses, parabolas, and hyperbolas are all shapes formed by slicing through a cone at various angles. Conic sections. It's hard to tell the difference between orbits shaped like the conic sections, especially very near the sun, where an orbiting comet would be bright enough to be seen from Earth. What's this on page 13? Okay, so page 10, Crazy Jet Propulsion Laboratory. Oh, is it this one? Oh, looks like I missed this page. When Halley appeared in 1531, medieval Western astronomers finally realized that comet tails always point away from the sun, something the Chinese had known for at least 9 centuries. Page 10, Courtesy Jet Propulsion Laboratory. Page 11, Courtesy Library of Congress. Johannes Hebel II Chromatography in Chromatography Hevelius included a sketch of Comet Halley at its return in 1607. Third from the top. The true nature of comets and their orbits was a hot topic in the 17th century. This illustration from Johann Hevelius Chromatographia, published in 1668, shows 3 scientists debating the issue. The man on the left holds that comets are very near the Earth, as Aristotle has suggested. The one on the right agrees with Kepler's view that comets move in straight lines. A scientist in the center argues that comets move in parabolas, the view put forward by Hevelius. See what's going on up there. We'll use some instruments. And then these gentlemen down here trying to figure out with math how those comets move. And none of them are really right. Especially not Aristotle, unfortunately. Hevelius was closest to right, but Kepler was all like Kepler and Aristotle were both very incorrect about what comets are and how they move. As much as they were right about other things. Hevelius included a sketch of many different comets, and this is very, very small and grainy and hard to read. Yes. A little bitty one. Comet 1607. We need to find better photos of these. The German astronomer Otto Struve made this detailed sketch of Halley's appearance through a telescope in 1835. What's this? Page 14. Page 14, top courtesy JPL. Left courtesy Library of Congress. In January 1759, the Hamburgisches Magazine announced Johann Pallich's recovery of Halley's comet. Edmund Halley's bold prediction had come true. Here's that in German. Der Comet. Welchen die Astronomen. See, those old S's look like F's. Astronomen bisher so sämtlich erwartet haben. Wahrscheinlich namentlich, welcher 1682 sichtbar gewesen und nach der Newtonianischen Theorie von Haller am ersten unter allen Kometen mit Überlassungszeit auf die gegenwärtige Zeit vorher verständigt worden ist wirklich erschienen wollen ist so nicht anders als nur durch Fernglasser wollen ich mich eines I'm not sure what that letter is. Is it a I'm looking to see what this letter even is. Looks like a D. Drenschuhigen Astronomischen I'm not sure what that is. Is it a J? Is it an I? No, it's not. I don't think it's an I. Shubi Bennett. Warhen Man werd ein aber in der Folge. Is this a cut? This is a fancy S, maybe? Would be an S. Shubi. So in der Folge der Zeit, desto anfänglicher Erblichen. Ja, word unter die sogenannten großen Kometen mit recht zu sammeln nur das. All right. I tried. I only know some of them words, and this is very archaic, 1759 German. And then, so established returns of Halley's Comet.
For me, please.
So date of perihelion, March 30th, year 239 BC. All right. October 5th, 163 BC. August 2nd, 86 BC. October 5th, 11 BC. Okay,